Okay, welcome. This is a video series that's going to help us understand adding and subtracting, multiplying, dividing rational expressions, and later on take a look at their domains. So the first thing I want to do is review the old school fraction operations. That is that what do we need to know about adding and subtracting, multiplying, dividing fractions if they were just numbers, no polynomials, or any algebra involved. So this first guy, we got addition and subtraction going on, and we know from our schooling in the past that we're going to need some common denominators to knock these things out. So therefore, is that we want to get the denominators equal to one another by some fancy multiplication to the top and the bottom, and then shore up the final answer afterwards. So what we do is that we ask ourselves, what is the lowest number that a 5, a 10, and a 20 divide into evenly? We know that that number is 20. Okay, and so therefore, I'm going to see if I can get these denominators equal to 20 by multiplying the top and the bottom by the same number. So how do I get a 5 to look like a 20? I got to multiply the top and the bottom by a 4, and that is going to give me 16 over 20. And likewise, how do I get a 10 to look like a 20? That is going to go ahead and let's see, multiply the top and the bottom by 2, and that's going to give me 6 over 20. And then 20 is already looking like a 20, so now I just have to add and subtract straight across, keeping the denominator the same, and so I get 20. 16 plus 6 is 22 minus 1, that's 21. And so it looks like my answer is 21 over 20. When I am multiplying straight across, or I should say just multiplying fractions, I can multiply straight across the numerators and the denominators. That said, is that I can also use the technique of canceling out, or cross-canceling across different fractions. For example, the 3 here can cancel in the 3 once, and the 3 could cancel into a, pardon me, 6 twice. And that gives us lower numbers, so it helps us multiply quicker. So what we're looking at is 1 times 5 times 1 is going to give me 5. 4 times 2, 8 times another 2 is going to give me 16. So my solution is 5/16. Now with the division, what we have to go ahead and worry about is flipping the second fraction, so we got to go ahead and take the reciprocal of that, and we have to change this division into a multiplication. So let's go ahead and rework this here, and now we have a multiplication problem where we can again cross cancel. The 3 goes in the 3 once, 3 goes in the 6 twice. And so if we multiply straight across, we end up with 7 over 10. So those are the rules that we have to reflect upon when we are doing the rest of these polynomial exercises. And so let's go ahead and cut to the next video and see what we got in store here. Okay, continuing with the video series, just some things that I want to go ahead and make sure that we got nailed down before we progress is how to find the domains of rational expressions, and just factoring the simplify, which is going to go ahead and be resolved here in those boxes. Now, one thing that we want to remember is that anything, for example this, 0 divided by anything is going to go ahead and give us 0, except when you divide by 0. So, but for the most part, 0 divided by anything will give us 0. However, when we divide by 0, that's going to be undefined. And we're going to not explore that concept in this video. It's just something that we have to put in our back pocket. And when we divide by 0, understand that it's undefined. So if we have functions like this guy, or I should say expressions, we're trying to look at what can't I plug into 4 divided by x minus 3 to make it not undefined. So to do so, I think about, okay, well, what is going to make the bottom equal to 0? So I go x minus 3 is equal to 0. And I reveal that x, when it is 3, the bottom is going to be the 0 and therefore undefined. So the domain, as I write, is going to be negative infinity up until 3 union 3 to positive infinity. Okay, so we're just excluding the 3 because we know that when we plug it into that expression, it's bad news because it's division by 0. Now, with this one, we got some stuff going on in the denominator that looks like it needs some factoring. This guy up here, we're not going to worry too much about. We're worried about the denominator because we learned that division by 0 is really the bad thing, and 0 in the numerator is doable. So let's take a look at picking apart this denominator and seeing which values are going to be bad. So I got a 4. What is going to... Sorry about that. What is going to go ahead and multiply to a 4 and add to a 5? And the answer is 4 and 1. 4 times 1 is 4. 4 plus 1 is 5. So therefore, the denominator is going to look like this. So now we take this and we apply the zero product property. And we say, okay, x plus 1 equals 0, x plus 4 equals 0. So what are the numbers that are not going to work for this particular denominator? So we find out that x equals a negative 1, and when x equals a negative 4. So to write the domain out in interval notation, we end up with the domain is a negative infinity to a negative 4, union negative 4 to a negative 1, oops, pardon me, union negative 1 to a positive infinity. So it's just excluding these values, so we know that we can't plug those in and create an undefined situation. Okay, so that's the way that domains work. Just trying to go ahead and scoop out the values that when we plug them in for x, it's going to make the bottom go to 0, and you're going to have an undefined situation. Something else that we need to go ahead and do out is factoring and simplification. So sometimes there's going to be a common hidden term or binomial or trinomial that's in the numerator and denominator that could go ahead and cancel out. And sometimes we have to factor to reveal it. So for example, if I look at 3x plus 15 divided by x plus 5, I could factor out a 3 on top and the bottom, and that is going to leave me with something that is common on the top and the bottom, the x plus 5. That will cancel out, and this particular expression will just go ahead and reduce down to 3. So that means is that x plus 5 is common on the top and the bottom, so 3 is the only thing that is left. Now, sometimes we need to go ahead and factor the top and the bottom to reveal what is going to be in common, and then go ahead and cross them out, or I should say cancel them out. So what two numbers are going to multiply the 2 and add to a negative 3? And what two numbers are going to multiply to a negative 10 and add the 2? So it looks like I'm going to a negative 1 and a negative 2 here is going to work for that guy. And just playing around with some numbers here, I get a 5 and let's see, negative 2. Oh, no, you know what? I made a mistake. This is going to go ahead and have to be a 3 down here. So that's going to complete everything. So my apologies about that, because it has to go ahead and multiplies that and adds that. So now, factoring everything out, it's going to look like this, where we have an x minus 1, x minus 2, all over x plus 5 and x minus 2. So now, after we factored it out, we can see that there's a common term on the top and the bottom. That will go ahead and cancel out. And our final simplification is going to be x minus 1 over x plus 5. And that's a real important skill to go ahead and have as we move and progress along this particular video series. And so let's go ahead and get our hands dirty with adding and subtracting polynomials that have like denominators coming up next. Okay, with this video series, we want to go ahead and take a look at some of the techniques that are, not only arithmetic and whatnot, but just to go ahead and refresh these things about factoring, canceling, etc., etc. So, let's go ahead and take a look at what happens when we have to factor out a common term and factor again. So if we look at this guy right here, it's a quadratic, and it looks like from an 2, an 8, and a 42, we could factor out a 2. So oftentimes we're going to have to factor out a common term before we start factoring the actual quadratic itself. So you notice that I took a 2 out of every one of those terms, and now I'm left with this that I can apply the multiply. Okay, sorry about that break in action. What multiplies to a negative 21 and adds to a negative 4. And it appears that that is going to give us a negative 7 and a positive 3. So I know that I got 2, and that's going to go x minus 7 and x plus 3. So again, that's really important that we're able to break things down that have multiple parts. Also, we have this business of the difference of squares, and sometimes setting up the different squares takes factoring out that common term. So we notice that a 2 and a 72 has 2 as a common term, so we can go ahead and factor that out using the reverse distributive property, and that's going to give us x squared minus 36. Now we know that this is the difference of squares, and so that's going to give us 2 x minus 6 and x plus 6. And so therefore we have broken that completely down, and yeah, that's going to be a very, very important trick to have in our back pocket while we're trying to go ahead and make sense of simplifying these rational expressions. So, on to the next skill, if you will. Okay, once again, it looks like some more skills that we need to be prosperous with this particular section, and this one revolves around what happens when you don't have a common factor with the quadratic, and on top of that it has a leading coefficient that is not 1. So to do this out, what we need to do is multiply the leading coefficient and the constant, and that's going to give us x squared minus 13 plus 40. And we practice this in class quite a bit, and so therefore we know that we are asking what two numbers multiply the 40 and add to a negative 13. And so it looks like I'm going to go ahead and say that a negative 8 and negative 5 is going to go ahead and work. And so therefore we end up with x minus 8 and x minus 5. Now, since we went ahead and we multiplied by that leading coefficient there, we know that we need to divide that number to the terms in which these guys were basically brought from, and that's going to complete our solution. So first thing we need to do is simplify. So we got x minus 8 divided by 2, which is going to turn into x minus 4, and if it doesn't go ahead and divide it evenly, we know that we have to put that term in front, and so that ends up to a 2x minus 5. And that, I know that's something that we practice in class and basic skills, or just, from homework assignments and whatnot, but it's something that we need to go ahead and have down before we really go ahead and delve into the section. Now, difference or sum of cubes is another thing that may come up, even though it's not as prominent as, things such as this guy. But if we run into the sum or difference of cubes, it's important for us to not only, keep in mind these kind of like factoring patterns, but at the same point be able to break this down so we can identify the A's and the B's that are in this factoring pattern. So it looks like we're going to be breaking this down and using this right here because it's a sum of cubes, whereas A is an X and B is a 2. So we're going to go ahead and plug. Every time that we see an A, we're going to plug in an X. And every time that we see a B, we're going to plug in a 2. So this is how we're going to factor it out. We end up with X plus 2. And I think I made this arrow a little bit too big, so let me back that arrow up. And I end up with X squared minus 2 times X plus 2 to the second power. And now we're going to go ahead and put the final touches on everything. X plus 2, X squared minus 2x plus 4, and that's factoring the sum of cubes for x plus 8. Again, it's not something that comes up often, but we should have as many tools in our back pocket as we progress through this particular section. Okay, one last skill that we need to go ahead and discuss before we get started is this business of flipping signs with negatives and canceling out common terms on the top and the bottom. So let's get started. Okay, so for example, if I were dealt this and I wanted to flip the signs, I know that I could factor out a negative sign, and that is going to flip every sign that is within the polynomial, in this case a binomial. So if I factor out a negative, I know that every sign inside the parentheses would flip, and it would look like that. To prove that it works, I could put the negative sign back in, and I would have a negative x plus 6. So I know that these guys right here are going to be like forms, and I could rewrite them to possibly do some canceling out, which is something that we're going to see in the next example. So this guy right here, we want to go ahead and factor and maybe do some canceling out. Now I know that these, kind of like playing a chess player, is that I want to see if it can factor out, or cancel out with the bottom right there. So I notice that if I factor out a negative 2, I'm going to be left with an x minus 3, which is going to match the x minus 3 on the bottom. So therefore, I could cancel out that in the numerator and the denominator, and I end up with this just simplifying down to an negative 2. So that's why factoring out a negative is important, is that sometimes you can switch the signs on your polynomials and allow them to go ahead and cancel out. So this next guy right here is a little bit different. It has to all do with counting what is top and the bottom. So I'm going to, when I have these, I like to go ahead and create a division bar, and then I like to simplify everything separately. So for example, what does 4 over 10 reduce down to? So I know that a 2 is going to divide into 4 twice, and a 2 is going to divide into 10 5 times. So there we go. That's the first part of simplifying that out, is just taking a look at that business of the constants. Now, what we're looking at now is the x's. So how many more x's do I have on the bottom and the top? And that's 2. So I know that I'm not going to have any x's on the top, but I'm going to go ahead and have 2 left on the bottom. So that is going to complete that process. I also know that the y's are equal on the top and the bottom, so they'll all cancel out. So I won't have any y's on the top or the bottom. So it ends up being just like a nice canceling out, and nothing is owed, nothing is gained. And likewise, with the z's, I know that I have a z to the 5th and a z to the 2nd. There's 3 more z's on the top and the bottom, so I got a z to the 3rd on top. And so I know that this is going to be my final simplified solution for that, just out of looking at what is the ratio of the number of variables to the top and the bottom, or the ratio of the constants that are out in front. Now, this final one, trying to go ahead and think, alright, well, how am I going to simplify this guy out? The x minus 3's we know go out because that can go out on the top and the bottom. Another thing that we could cancel is that 4 goes in the 4 once, and 4 goes in the 8 twice. And so at the end of the day, we end up with x, sorry about that break in the action, x plus 2 and 2x minus 2. And that's all that we can reduce it down, as we can't get anything more like to simplify this down into something that we want. So that concludes kind of the things that we want to keep in mind before we delve into this lesson. So let's go ahead and get into the meat of the lesson and where the rubber meets the road. Okay, in this next video, we're going to go ahead and tackle kind of the crux of the lesson, or starting with it, where we add, subtract, and then simplify our expression. However, in this kind of like for example set, notice we have like denominators and we have no simplification. So that means is that when we're adding and subtracting fractions, we know that we need a like denominator to enable to do so. That said, since it's kind of rigged for us to go ahead and have a like denominator, this is kind of like easing us into this process of adding and subtracting before we actually have to deal with the complications of that. So, if you look down below, I'm going to go ahead and present this problem. 3/8 plus 1/8. And from there, what we're going to go ahead and do is that we're going to recognize that denominators, when they're like these 8's right here, stay the same, and it's going to have an 8 as a bottom. And we add the 3 plus 1, that's going to go ahead and give us a 4. So we got 4 8's. Now, from there, we're going to go ahead and simplify to 1/2. And if we keep this, albeit very simple, arithmetic that we've seen in the past, if we keep this in mind while we're doing our examples here, I think that that's going to go ahead and help us understand how to do these problems out. Now, granted, there's not going to be any simplification or reduction at the end of these examples, but still at the same point, it's important to keep in mind this type of example, so that's going to feed us into the whole algebraic scheme here. So, notice we got some like denominators here. We're going to go ahead and take a look at this example number 1 here. And since we have the same denominators, this x plus 5, what I recommend that students do is that we put x plus 5 as the denominator down below. And then what we do is that we go ahead and say 4 plus 7 up top, 4 plus 7. And then simplify it out, and that's going to go ahead and give us 11 over x plus 5. It seems kind of a peculiar way to carry things out, but it's going to make sense in some of the videos that are going to follow. For the second example, you notice that we have a subtraction problem. same type of denominator that happens to be the same, x plus 5. And then we end up with 5x minus 2x. So we got 5x minus 2x. And that's going to simplify down to on top, on 3x over x plus 5. Okay? And there's no reducing or anything like that to go ahead and be had. And so that's our final combining the two fractions and doing it out. X plus 3 in example 3 is going to go ahead and be our common denominator. And then we go ahead, it looks like we actually have a binomial, so we got in parentheses 2x minus 7 plus x up top in the numerator. So simplifying that out, we know it's addition, so we can drop the parentheses. We gather those guys up, and we end up with 3x minus 7 all over x plus 3. Once again, we're keeping in mind there's no simplification to go ahead and be had. That's coming later in the videos. We're just looking at easing into this process. And then for example 4 here, we have, again, like denominators of x plus 3. Now, this is where parentheses are super important. So we end up with this minus this. So we end up with 2x minus 3 parentheses minus 5x plus 1. And without the parentheses, a lot of times the students forget to, flip the signs of this binomial here, and it messes up their calculations. So we're going to keep that in mind and put that negative into those, flipping the signs. And so we're going to have an in-between step of this right here. We got some work to do in the the numerator. Denominator stays the same. And now we have to clean this up. We got 2x minus 5x, which is going to give us a negative 3x. And then we got a negative 3 minus 1, which is going to give us a negative 4. All over x plus 3. And so that is going to go ahead and do this out, and that's going to be our final solution, or our final simplification. We could also, by the way, some folks like to go ahead and do this when they got double negatives right there, is that they factor out the negative. And it's something that looks like that, though not necessarily, needed for absolute correctness. But just mind yourself that it could be the way an answer is presented, because that's pretty common in mathematics. To if you have two negatives like that, to factor it out just to have the negative in front. So. That's how you do the like denominators, no simplification, and so on to the next video. Alright, here we are at the next video that is going to go ahead and still have the same like denominators. However, at the end of kind of like putting everything together, we're going to have to look for some stuff to simplify out. That is that find some common terms on the top and the bottom and see if they are, if there's anything in common where we could cancel out. So, here we go. Okay. For this first one, it looks like we have common denominators. We have x plus 5 times x minus 3. It's already factored for us, so it's very convenient. So we go x plus 5 times x minus 3. Oops. And then up top, we're going to go ahead and set it up so when we combine everything out, it is going to be algebraically correct. So you want to take the numerators and have this minus this up top and put it all over one denominator just for quality of life. And so we end up with 2x. Oops, let's do this. Let's show all the steps here. Let's distribute the negative and drop some parentheses, so we end up with 2x plus 7 minus x minus 10 all over the previously given to us factored denominator. Okay, and now we have some like terms to knock out. Okay, so we end up with 2x minus x, which is x. 7 minus 10 is negative 3, all over our denominator. And so it looks like we have something in common in the top and the bottom where we could go ahead and cross out, and we end up with 1 over x plus 5. Notice not just x plus 5. A lot of students will put that on accident, forgetting the 1 up top, but you do have to remember that if it's in the denominator, it has to stay in the denominator. Okay, this next one is very similar to the example up top, except we are not given a denominator that's factored. So we have to go ahead and factor this out. Even though it's a like denominator, we want to go ahead and factor out just to see if there's something that at the very end is going to cancel in the numerator and denominator. So we ask ourselves, what multiplies 6, adds to 5, and that's going to be 2 and 3. So we know that we could factor that denominator into x plus 2 times x plus 3. Okay, and now let's set this up just like the example above. I get 2x minus x minus 2 all over now the factored denominator, which is x plus 2 times x plus 3. And we start doing this distributive property, which is going to help us rewrite like this. Okay. And now we want to collect up some like terms and see if anything is going to factor out. So I know that 2x minus x is just x, so we end up with x plus 2 because the 2 is all by itself there. And we got x plus 2 over x plus 3. We can see that we have something common on the top and the bottom again. That's going to cancel out. And we end up with 1 over x plus 3. Again, don't forget the 1 over part. It's not just x plus 3. Okay, and then finally we got a lot of stuff going on here. We got this business of x plus 3. And that's supposed to be a small x. I don't know why it's a big x there. But since it's a common denominator, we can rewrite everything over that one common denominator. And we got a lot to write up top because we got x squared plus 5x plus 1 minus 4x minus 5 plus 7x plus 9. Okay? And so, at the end of the day, we want to collect, or we want to break it down so we can start to collect like terms. X squared plus 5x plus 1 minus 4x plus 5 plus 7x plus 9 all over x plus 3. So now we got some like terms to collect. Notice that x squared is all by itself. So we end up with this x squared up top. However, we got 5x minus 4x, which is just x. Oop, looks like I forgot an x there. And so it is going to give me an 8x up top. Because again, 5 minus 4 is 1, plus 7x is 8x. And then we also have, let's see, we got 1 plus 5, 6 plus 9, that's 15. Okay, and then it is going to be all over x plus 3. And up top, it looks like we got something to factor now. And we want to factor that just to make sure that there's nothing that we could, or there might be something that we could cancel out with the denominator. So what two numbers multiply to 15? Add to 8. That's 5 and 3. So we know the top is going to be x plus 5 times x plus 3 all over x plus 3. So it looks like we got a winner where we could go ahead and cancel that out. And we end up with x plus 5 as our final solution. Notice that that does not need a 1 over x plus 5 as it is in, the denominator, or the numerator there. So, anyhow, that's how you do that, and on to the next examples. Okay, here we go. On to the inevitable, the unlike denominators. And one of the things that we want to go ahead and do is that we want to understand how to make some like denominators. Like in this this first guy right here. We got x, and we got 6x squared. So, if we were to go ahead and take a look at knocking these things out in a factored version. So say if I were to go ahead and write this as, look this, 7 times x. We notice that we would have an x in both of those fractions. However, to make them to have a common denominator, we'd have to also have a 6x extra on the first fraction here. So I'm going to multiply the bottom and the top by a 6x to even them out. So this is going to go ahead and create the following. I would have this guy, which is going to be 6x squared, where we know that that is going to be a common denominator. And so now I have to clean up the top, which is going to be 6x times 4, which is 24. Oops, that didn't look like a 24. 24 x plus 7. Now, as stated earlier, there's nothing to go ahead and simplify out, so this is the combined form. Now, with something that probably doesn't require much factoring, we just have a 2 and we have an x plus 3. So the way that I figure is that this one needs an x plus 3, and this one needs a 2 to the top and the bottom. So let's finish that thing off. So we'd have this, which is an x minus 3, and this one needs a 2. So we can see that when these denominators are going to, these guys are going to go ahead and be the same. They're both going to, if you're a chess player, it's going to be 2x minus 3. So we know we need to go ahead and do that to the top and the bottom here of the numerator. And now let's set this thing up so we can go ahead and simplify it out as much as we can. So this is going to give me x times x minus 3 minus 7 times 2, which is 14. Okay, and so let's go ahead and do some distribution. We end up with x squared minus 3x minus 14 over 2x minus 6. So it looks like we are all set here. We know that the top can't go ahead and be this top can't be factored out because there's nothing that's going to multiply to a negative 14 and add to a negative 3, and so therefore we end up with this as a final answer. Now this guy, we have 5 divided by 2x plus 3, but we're going to treat that like a 3 over 1, okay? And so the reason why is that we want to create something that is familiar to us that that we can go ahead and work with. So that said, what we want to do is that we want to create some common denominators, and it looks like the right fraction needs a common denominator because it's just a 1. And so we can create a common denominator by multiplying 2x to the top and the bottom. That's going to give us 2x, 2x in the denominator, okay? Because that would be 2x, and that would be 2x. And now we need to clean things up. We get 5 plus 6x. Looks like that's all that we can do. So I'm going to put that in standard form. 6x plus 5 over 2x, and that is going to be our simplified version. Okay, and then finally, we have 5 divided by x plus 2 to minus 1 divided by x minus 5. So the way that I'm going to see this is that this needs an x minus 5, and this needs an x plus 2. Okay? So we would have together x minus 5 times x plus 2 and x minus 5 times x plus 2. However, we need to multiply up top what we multiplied to the bottom, just like any fractions. And now we can start to put this together and simplify it out. So we end up with 5 times x minus 5 minus 1 times x plus 2. The minus comes from right here, remember? All over x minus 5 times x plus 2. Okay? Distributive property, clean up, and that should be the end of it. We'd end up with 5x minus 25 minus x minus 2 all over x minus 5 times x plus 2. Okay, collect some like terms. So we end up with 5x minus x, which is going to give me 4x, and 25 minus 2, which is negative 27, all over x minus 5 times x plus 2. Okay, and that is going to be the final simplification there. So, in the next video, we're going to go ahead and take a look at what happens when we have to simplify. But this is just something that is a first look at how to start things that have unlike denominators. Okay, here are a couple examples that have unlike denominators, and this time we require simplification. So that means we want to go ahead and do things all the way down, and after we perform the operation, addition, subtraction, etc., and see what cancels out. So one of the things that we have to do, like example number 1, we have unlike denominators, and we want to go ahead and factor just to see what the denominators, the x minus 2 and this trinomial here, have in common. So the easiest way is to factor it out. What two numbers multiply to negative 12, add to 4. So it looks like we're going to go 6 and a negative 2. So that means I can rewrite that bottom as x plus 6 times x minus 2. So I'm going to rewrite this, and also I'm going to see if, well, you know what, I'm not going to go ahead and do that quite yet. I'm going to just rewrite this like the following. So I have x plus 2, or x minus 2 rather, and then I have x plus 6x minus 2, and then I have my denominators, or numerators rather, that have stayed the same. Okay, and let's see where this takes us. Okay, so to do this out, and I'm going to move this little arrow sign here, just give me some more room, is that I have an x minus 2 for each one of those guys. So it looks like I need an x plus 6 to the top and the bottom here to create that like denominators. So now I got quite a bit of work to do. So I have x plus 6 times x minus 1 minus x squared plus 4x minus 4. All over this x plus 6, x minus 2. Okay, so now, just like the other examples we saw in the previous video, we got to go ahead and really take some time and clean up that numerator. I'm going to go ahead and start by doing a FOIL here first, and then doing this distributive property. So I know via FOIL, let me just go ahead and do it right down below here, so we're not doing a bunch of stuff. So I'm just going to FOIL this guy right here. That's going to give me x squared, minus x plus 6x minus 6, and those guys are going to go ahead and collect up. And so I end up with x squared plus 5x minus 6. And I'm going to subtract the other trinomial in the numerator, like that, and put it all over the x plus 6, x minus 2. Okay, and so I'm going to now, I should have flipped the signs already, but I didn't. So, one extra step, x squared plus 5x minus 6 minus x squared minus 4x plus 4 all over this stuff here. Okay, and now we got some collecting like terms to do. Looks like I got x squared minus x squared. That's going to go out. That's good, because I know I won't have to do some factoring later on. And I end up with 5x minus 4x, and that's going to give me, well, I was going to start writing the numerator right there. It's going to be x, and then negative 6 plus 4, that's a negative 2. All over this. Okay. And it looks like, as promised, something is going to go ahead and cancel out the top and the bottom. So I end up with x minus 2, dividing out with x minus 2, and I end up with 1 over x plus 6 as my final simplification. Okay, for this next example, there is a bit of a typo. I apologize about that. This should be a minus sign. And so let's proceed from there. Otherwise, nothing simplifies or cancels out, which is kind of the objective of this video. And I want to keep with that motif. And so let's change that to a minus sign and get ourselves ready to do this out. So, if we need some common denominators, because we have unlike denominators, we need to go ahead and factor everything out. And for this example, we're going to use the difference of two squares to go ahead and break apart this business of x squared minus 4. So, we end up with x minus 2, x plus 2 as the denominator of the leftmost rational expression. And I'm going to go ahead and rewrite this. Being a bit of a chess player, just to go ahead and leave some room for things that I know that we're going to need to do, like multiply the top and the bottom by some expressions. So the leftmost function breaks apart into this. Okay, and I got a minus, and I'm leaving a space just to go ahead and I know that we're going to have to multiply the top and the bottom by something for this second expression as well as the third. And then we have a minus 1 over x plus 2. Okay, so we know that this is going to go ahead and be the common denominator. So we're looking at, well, what is this guy missing, and what is this guy missing to be a common denominator. And it looks like if I multiply x plus 2 to the top and the bottom of this guy, and x minus 2 to the top and the bottom of this guy, I'm going to go ahead and get some common denominators. So I'm going to lift the whole thing up and put it over here, and we're going to get over one common denominator, which is x minus 2 times x plus 2. We're going to get the x squared. Okay, trying to go ahead and make this all over 1. And in the bottom here we got x minus 2, x plus 2. And then I got this minus sign here, so we get a minus x times x plus 2, and a minus 1 times x minus 2. Okay, so now I want to go ahead and just work on the numerator here and then start canceling stuff out. So I got x squared, and then I got to go ahead and distribute that, which is going to give me a negative x squared minus 2x, and then distribute that guy, and I get a negative x plus 2. Okay, and so if I'm collecting up like terms, I know that these guys are going to go to x squared, and then I have this, which is a negative 3x, and then a plus 2, all over now x minus 2, x plus 2. Okay, so it appears that I can go ahead and factor the top in hopes that something will cancel out. So what two numbers multiply the 2 and add to a negative 3? So we're going to get a negative 2 and negative 1, and that is going to give me an x minus 2 times an x minus 1 all over x minus 2, x plus 2. Okay, and so we can see that we have x minus 2 common on the top and the bottom. Those are going to cancel out. And so at the end of the day, we have our final answer of oops, I put that a little bit too far over, x minus 1 divided by x plus 2. And that is going to be our final solution. So, these are examples that, again, I arranged and picked that we're going to have unlike denominators that when you click them together, they're going to go ahead and cancel out. And that's how you do that. So on to the next part, which is going to be multiplying rational expressions. Okay, here we are at multiplying rational expressions. And the good thing about these is that basically you just have to go ahead and factor and then cross out as needed, or I should say cancel out as needed. So let's go ahead and do this. And I'm going to do this a bit of a kind of like a slower pace for those folks that are not real comfortable with the exponential rules and whatnot. So you might see some stuff that you can take a shortcut on. So feel free to go ahead and do so. But if you're someone that doesn't need a shortcut, then there's that too. So here we go. Okay, here we go with the first one. Kind of factoring out old school style. So what we got to do is that we take each numerator and denominator and factor it the best that we can. Oops. And see what is going to go ahead and cancel out. And you don't have to do it every single time like this if you're someone that already is really good with factoring and crossing stuff out, or canceling stuff out. But if you're not, this is a safe way to do it. So you cross out basically or cancel anything that is going to be on the top and the bottom. So you notice that, and going back, I shouldn't have done that without saying anything. The 3's cancel out. The x's cancel out. It has to be top and the bottom. These 2's are going to cancel out. And the y's are going to cancel out. So what is left? So it looks like we just have x times 2 times y, which is going to give us 2x y to the second, all over 1, because everything cancels out, so we just end up with 2x y to the second. Okay, so for this next one, anytime that we're multiplying and we just have something that is going to be a term, we want to think of it as basically just over 1, so we can set it up so we can cancel things out. So we end up with x minus 5 all over 1 times this guy, which it looks like we can pull an x to the second out of there, because each one will have an x to the second to give. And so I'm going x to the second, and that's going to leave me with x minus 5. So I do believe that these are going to be common, and so we are left with just this right here. And so at the end of the day, we end up with 7 divided by x squared. Okay, so here we go to the next one here. So it looks like we have x squared, or x plus 2 squared here. So it looks like we got x plus 2 times x plus 2, okay, all over 3 times 2 times x times 3x all over. Now this is the difference of two squares right here, so we go x minus 2 and x plus 2 from lessons past. We should know that. So here we go. That is going to cancel with this. These x's are going to go out, the 3's go out, and looks like everything else stays. So we end up with, on top here, the x plus 2 all over 2 times x minus 2. So I'm just going to go ahead and leave it as this. And that would go ahead and suffice as an answer. This guy I'm going to go ahead and drop down a little tiny bit because I'm running out of room. So I have 3x plus 2 all over 2x minus 1 times, and this I want to go ahead and talk about kind of playing a little bit of a chess game here. Is that I know that these guys right here are going to cancel out. I could see that ahead of time. However, it looks like I could do something to, especially this right here, where I could factor something out to make it look like this guy right here. So I'm going to do something different, and I'm going to factor out a -4, and that's going to flip the signs that are that are going to go ahead and be in that term, and that's going to give me a 2x minus 1, which is going to go ahead and match this and get those to cancel out, and those guys are going to cancel out as well, and so it looks like my final answer is going to go ahead and be a -4. And so far so good. We got a lot of good stuff going on here, and now we have this guy that is going to have lots of factoring to do, and yeah, we can talk about factoring, but I think what I'm going to do is that I'm going to factor them out ahead of time. So I'm going to take a pause, and then I'm going to factor them out, and then we're going to cross some stuff out, and yeah, see how that goes. Okay, here's a resumption, and basically I went ahead and factored each one of these guys, just a quality of life thing, and really just kind of saving space and assuming that you can factor stuff out. And so if you can't, you might want to check out some of the factoring videos and whatnot, but right now we're just working on canceling stuff out and seeing what is going to be left over. So it looks like we got x plus 5 and x plus 5 cancel out. We got 2x minus 1, 2x minus 1, 2x minus 3, and 2x minus 3, and x plus 1, and x plus 1. So it looks like everything cancels out, and so we are left with, ta-da, 1. And so sometimes that happens, and just one of the things that we want to make sure that we, when we have things of this ilk, that we simplify them down, because it could, be something that multiplies out to 1, and we don't need all that stuff, and that would simplify our expression enormously. So, on to dividing these rational expressions. Okay, here is kind of the last video about just simplifying, and this has to do with this business of dividing. And so, basically it's the same thing that we practiced when we were multiplying, except for we need to flip the second fraction that we're dividing by. That is take the reciprocal of it and then change it into multiplication. So let's go ahead and do that. So my first step is, when I'm doing this out, I need to change this into this type of statement. So I'm going to flip-flop that and take the reciprocal, and now I have this all set up. And now, much like when we were multiplying in the last video, what we want to do is factor everything out and see what cancels out. So I know right here I got the difference of two squares, so that is going to factor into x minus 3 times x plus 3 all over x plus 4 times x plus 4 all over x minus 3. And so we can see that we got some stuff canceling out here. So I got that and that going out, that and that going out, and it looks like our final simplification is going to be x plus 3. Okay, and so this next guy, when we have something that we're dividing by, it is easier sometimes to envision it over 1, and simply because when we are going to set up this step right here, okay, we're going to multiply it, and that helps us keep this calculation or this step straight. Okay, so now we need to factor some things out. Okay, so this guy we need to factor, saying what two numbers multiply to 15 and add to 8, 5 and 3, and so we end up with x plus 5 times x plus 3 all over x squared times 1. And when we have this squared like this, I like to envision it as x plus 3 times x plus 3. And now it's time to go ahead and cancel some things out. So it looks like we're going to knock this down, doing that and that. And it looks like that's everything that we can do. So we end up with x plus 5 all over x squared times x plus 3. Okay, so that is the final simplification there, and it looks like we have something that is going to be, for this next example, lots of factoring out to do. So let's go ahead and set it up first, and then walk our way through this whole factoring process. So I have that guy, which is a numerator technically, and divide it by, and we're going to flip this on over, and now we got all kinds of good stuff to factor out. Okay, so I'm going to pause for a minute and factor all these out, and then be right back. Okay, so all these, this guy right here, I factored all of these because I think we're pretty good with factoring. At this point, we've been practicing it quite a bit, and so we have some stuff to cross out here. So it looks like this is going to cross out with this guy. This is going to cross out with this guy. The x's are going to go ahead and go out, and so it looks like we are left with the 2 times 2 up top. So that's going to give us 4. 2x minus 1 all over 3. Okay, and so that's basically how you do those guys. Pretty straightforward. If you got the multiplication section, this should be no problem because it's just one added step. Change these division signs to multiplication, and then you flip-flop the second fraction, and you go about your factoring and crossing out merry way. So, okay, next up is going to be solving rational equations. So, onward.